Another question?
Okay. If any, again, you can grab Damien anytime in the day. In the night, I don't know, but so it's so next. I think next talk will be Damien as well. Okay, so Bruno found a way. So but it will be a different topic. We are moving from SofaPython to it's already written run Sofa 2, which is and we talked also shortly about that yesterday during the training. It was about a new GUI in Sofa. That's again a work that has been mainly led by the research team, which is located in the north of France, Defrost. And so Damien will carry on the second presentation.
Yeah, because I wanted to make live presentation, and Bruno was saying, "Oh, it will crash." I said, "Okay, let's try it." It may crash. It will. Okay. So the idea of this work was that actually we are using Run Sofa to execute our simulation, and there were now deprecated application that was called the modeler to help people to make scenes. And now it's deprecated, so we only have Run Sofa, and a lot of people complain or have difficulties to make simulation with just Run Sofa. So we wanted to smooth the user experiment with making Sofa simulation, especially in our team where we are making soft robots. And so the user we are focusing are roboticians, and so they are not quite happy to write Python code to make simulations. So the idea was to integrate auto-range features into Run Sofa, so we can design the simulation in an integrated environment. So our idea was that we want to be able to do the complete scene modeling, simulate and execute the simulation. And actually, the starting point of that was Project from the Manhattan Club. So thank you guys. They made a complete plugin to use QML, which is a graphical user interface framework, and they made a binding for this framework and application to connect that with Sofa. And if you are used to work with Unity, you will see that we lack of originality because we took a lot of inspiration from their work. In terms of feature, we wanted to have some scene graph editing, interactive modeling. We wanted a project-oriented approach. So this means we don't want to have any more scene file with data sets, assets, geometries everywhere. We want that to be into a specific project so we can zip it, give it to someone else, and it will work. We wanted to have some 2D user interface on top of the simulation, the ability for everyone to implement his own custom widget, graphical user interface on top of Sofa, some live coding features so you can edit interactively your scene and it's automatically updated. And recently, thanks to the work of Eric, he added some node-based interface. And we wanted something that is called a non-linear workflow, so you can add all the objects in any ordering, and it should work. So where is that? Okay. So now is the risky part. So far, so it's very close to what you are used with Sofa. So you can get actually the classical hierarchy of the simulation. You have the inspector that shows you the content, the data of each object. Here, with the parameters, and that's it. Well, a bit different with Sofa is that we split the view in two different areas. One is the editor, so it's the editor, and one is the simulation. So when we are making simulation, it was quite useful to differentiate the two. So in this one, the only thing we see is what the camera in the scene is showing, while in this one is the global view of the complete scene. So this is Sofa. What else could I say on that? because what we want to do is actually to be able to model scenes. So I will start with a fresh one, so a really empty one. And among the features we have added now is that if you don't like to write Python code to a component, you can do that graphically and interactively. Okay, you can add the object. Formats. There it is. This one is not expected. Okay. One of the features we like at Defrost is that I will show you the scene first. This one. We can visualize the connection between all the components in the scene. I don't know if you are used to Sofa, but each data or each component has a set of data and they can be connected together. And actually the consistency of this graph is really important to have a valid simulation. And so it's very important to be able to introspect where all the objects are connected. So I will start with my empty scene. And another feature we like at Defrost is that we want to make a reusable component. And for example, here, it's what we have done with what we have called prefab. So I will open here. You have here is the project view. So it's all the scripts, data, scene you want to manipulate in your simulation. And here you can, here is just a very small, what we call that a prefab. Is actually Python code with different parameters. And there is just one difference with the classical Python function, is that there is this decorator, and these decorators allow the code to be integrated into the graphical interface. And so now we can drag and drop this object to have it into the scene. And what I really like here is that we can access all the parameters here from the graphical user interface. Here, it's here. You have the prefab properties, so the file name, and actually here on this object there is no rendering, but there is a boolean, so we can activate it, and we can change everything interactively. And the nice thing is that with this, is that instead of manipulating each component individually, we can now share with other completely functional bits of objects in Sofa. For example, here, another one. So I want, we can look at the implementation here. And you can see it's just a for loop that repeats object. So you can write a kind of parametric object that you can then manipulate graphically and interactively. And here you can do these things. So you can then replace the sphere, because I am too lazy to make a super good looking demonstration, with something more interesting. The idea is that we want, it's actually what we have done in Defrost. We have a lot of these prefabricated elements that people can just drag and drop, which contain a complete, fully functional object. What else? Some of small features that we like also is that we can now access much more easily to the error message. Thank you. So you was right. Okay, it was not what I wanted to show. So this is just for speed. So I am lost. Yes, there is now some possibility to customize the user interface in two ways. The first one is that here. So basically in Sofa there is a lot of data fields, and it's often very hard to understand which one are the most important and which one are just useful for the simulation. So it's possible to get custom user interface for each component. So when you make your own dedicated component, you can have this specific graphical user interface here, a simplified one. And what you can do also, what I was saying here, the camera is poorly positioned. So you can also have some overlay layout on top of that. So it's a Canva, and I will use this file. So here, and the Canva where it is. Here is the file, and we can edit it then interactively. So I will open it in my editor here. So you can change. I don't know if it's very visible on the screen. So I am here changing the dimension of the user interface that is on top of the object. And then what I did, okay, I will remove this. Okay, I will remove this button just to start from a very clean thing. And then you can have, for example, a spin box, so to change a value. And here I'm just saying that this spin box is connected to the component that is selected, its position, and change the value. I don't know, where are my slides again? Not here. Okay, so did I forget? Oh, yes. One of the regular complaints we have is that there is not enough documentation in Sofa, so now you can just quite simply go to the documentation, and if I have a network connection, you can jump to the existing documentation that is on the website. What else? Yeah, the custom interface. Okay, so what next? Fix bugs.
Live coding?
Yes, if you want, I can show that. Here I am just using this prefab, and I will. Can I drop the mic? You present for me, I can do that for you. Okay, how can I show the live coding features? So here what I did is that I put one of the prefab I showed you before. Here it is, and I can actually just remove this, and the prefab is empty. So now you can do here I am just adding a mechanical object like that. So each time I save the file, you get the result here. And if you want to add a new parameter, you can add it here. And so here, basically, what we are saying is that there is 3 parameters to this prefab, which is what we see here. And actually, we use this parameter to activate the rendering. And so, like that. So now we have the visual model of the object, in addition to the force field. I will try one thing more if it doesn't crash. So maybe this info is better. So here, yeah. Too bad. Actually, I spent my night trying to fix some threading issue with Python 3. And that's why in the Python 3 code I say that we are in the process of upgrading to Sofa Python 3. So what I wanted to show was that how could I? Okay. So now you can see actually each time I am pressing, I am saving the file. You can see that. So here it's not really useful, but you can then do interesting things like what are the all properties for this object. Okay. No. Sorry, there is an invalid syntax, so I maybe have one too much. Yeah, here. So here it's a classical Python code to say, oh, can you tell me what are the different attributes of the self-object? So you can do some kind of introspection to your object. And what is quite interesting is that it's per component. So you can have, it's slightly different from a Python console where you access the simulation from the root level. Here, in each component, you can do some live coding into it. That's it.
Yeah.
Yeah, that's all for my talk actually.
Thank you, Damien. So I don't know if you all, if you all realize what those two projects are actually gonna, so Sofa Python 3 and also coupled to that the SofaQtQuick, so the Run Sofa 2 new interface may really change a lot of things in what is actually currently not possible and what will become possible with Sofa. So thank you, Damien, for the presentation. Is there any questions?
Yes. One thing. That currently in Sofa there is a lot of troubles we have with this, and a lot of problem and crash we have is that the Sofa components are not designed to be changed interactively. So there is no clear specification on how a component should react to a change of its data field. So some of them recompute everything, some of them recompute nothing. So basically, and this is really problematic into the user interface because when we change some value, some component will just not react to that. And so that's why I think there is a lot of discussion during the STC, the 2 next days, on how we could clarify that so that all the components have a kind of systematic and conformant behavior. Actually, this is what you can see, it's beginning here. We have added some state to the component, so we know they are in a valid state or they need to be updated. And so we can chain all the components together, and when one value is changed, all the component chain is updated. But this is not the case right now. So for example, I didn't show that, but I think I could try. If we create OGL model, and then I will add mesh oblige loader, so to load the mesh. And I would like these two to be connected. So I would say now I will not here do the connection. Where it is? Okay, where is it? The loader.
And meanwhile, you can prepare your questions. You already have one? Okay, so we already have. Do you take already the questions, Damien?
No, I just want to.
You have to be patient, actually.
Here. Okay, so here I'm just saying that I want to connect this loader to the. Okay, so now the connection is made, and now we would like, for example, that when this loader doesn't have a file, so when we add the file, we would like the OGL model to be updated, but this is not the case, because the OGL model doesn't update its content when one of its connected components is changed. But that's a major difficulty we have with to handle all the Sofa components. That's all.
Thank you very much for the presentation. Is there any questions? So there is one from me. So is there other questions? And I can write it.
Yeah, just quickly. Are you able to customize the GUI? Let's say, for example, in my scene I have two cameras. I would like to see both cameras at the same time.
Yes. So you can do that. You can implement. Okay, right here. Actually, this was from the original code base from Anatoscope. You can write your own custom view here. So, and actually, you can have live coding features on the graphical user interface here that you can write your own view with any content you want, 3D, 2D, widgets. And this will be part of the modeling tool. It will not be part of your scene. If you want to integrate into your simulation scene, this means that you expect to have some rendering with Sofa. You need to use the Canva I showed you. So it will be an overlay on top of the camera view. Another question?
There is another question, and indeed, it has just been mentioned by Damien. This work is actually derived from a first initiative that was led by Anatoscope based on the QtQuick, so which was called the SofaQtQuick project, and has been further pursued by the boss. So, a question of Vlad,
well, thanks for the talk. I have actually two questions. First, is it possible to export or build the scenes somehow?
Yes. So basically, compared to Run Sofa, you can save the scene. And let me show you. So we will add some child or something. No, child is here. And again, so I save it. Let's save that here. And so if I reload the scene, it's actually updated. So let me show the content of the scene. Open editor. Here is the scene that is generated. So we put some effort on being able to save. And basically the semantic we have chosen is that we save every value that is changed. In the current Sofa, when you want to save a scene with Run Sofa, it will save nearly all the data fields, which means that you edit your scene, then you save it with Run Sofa, and then you get hundreds of values everywhere. Here we only want to show in the scene what the value that have been changed, because we think that it's meaningful for the user to reconstruct the scene. Maybe I can add something. No. One new node. Yeah, something. And I think it will switch here. Yeah. So you can get that. And I think it will. Here I am saving a prefab. And the nice thing is that the prefab is also saved in a short form, so it will preserve the consistency of the prefab. And you can see that we detected that the prefab came from this Python file, and so we can add it with a one line in the scene. So we wanted the scene to still be very readable, to allow people to continue working the way they were used to, so straight from Python.
Will all of the features be available in that scene? Like, for example, KML binding, will it be available if you just save it as a Python code and you want to run it externally?
Sorry, you mean the QML code?
I mean as far as I remember, it's called Canvas.
Yes, the canvas is a software object actually, so it will be saved. Yes.
Okay.
So it's a classical object. Like that, and actually it has a file name which holds the canvas QML file. So let me show where it is. Okay, so if I save it, and here is the canvas line. So it's saved here in this way.
perfect. Thanks again. And the second question is, maybe it's a bit out of scope, but with canvas object, is it possible to use it in the 3D scene, or is it always attached to the camera, you know, like a heads-up display or?
So it's attached to the scene graph. Actually, the rendering is done on top of the 2D layers, but into this camera view you can get the projection matrix from the camera, and so you can put the canvas at the projected location, but you don't have a 3D object. You don't have like in the world space some text or any kind of. It's not the focus on that.
Okay.
It's really a 2D user interface.
Thank you.
So again, thank you, Damien. I think we're going to move on to the next session. So thank you again. Next session starts. Next session we will start talking about robotics.